Good morning, everybody. Welcome from Delft. This is the first training school of the SmartThings project. My name is Erik Schlangen. I'm from TU Delft and I will be your host this week. It would have been nicer to host you really in Delft, our beautiful city, but due to COVID, that's not an option. So we have to also have this event online, as many other events. But also this can be very interesting, very inspiring and also useful, because you can watch it by video from your home, in your own environment, behind your own computer and enjoying your own coffee. So make yourself comfortable and watch our event. We have people joining from all over the world, following the live stream. So for some of them it's very early in the morning, some of them already in the afternoon or late at night. So welcome to this event. I will explain you more about the content in a few minutes. What we do in this training school, who will be teaching, who will be presenting. But I would like to invite first our coordinator from the SmartThings project, Nele, Belie, to explain us a little bit more what SmartThings is about and what we do inside this project. So Nele.
Yes, good morning everyone also from my side. Welcome to this first SmartThings training school. So just something about SmartThings. SmartThings is actually a project sponsored by the European Commission, an international training network. So the real aim is to train a new generation of entrepreneurial early stage researchers, and then in the specific topic to prevent deterioration of concrete. And that includes as well new concrete infrastructure, which we want to improve in quality by innovative multifunctional self-healing strategies, but also existing concrete infrastructure where we want to apply advanced repair technologies. And we want to implement also new life cycle thinking strategies and durability-based approaches, all in line with Europe's circular economy. We want to move actually really beyond the state of the art. We want to improve the robustness of the self-healing concrete and still produce it at an acceptable cost for real scale applications. So we want to move one step up in scale to the real scale and not stick with the normal lab specimens that are usually investigated in projects on self-healing concrete. We also want to apply multifunctionality. So we want to combine self-healing with other functionalities like corrosion inhibition and self-sensing. And we want to make it cheaper by only applying the self-healing strategies in the high-risk zones and also in repair products and high-value grouts. Furthermore, we want to facilitate the introduction of all these novel technologies into the market so that we will improve the European innovation capacity in this way. And actually, one of the early-stage researchers is also especially investigating these models to bring new engineering technologies to the market. So that was the topic of the project. Erik, will you move the slides or?
I will.
Yes. Yeah. So, yeah, as you can see, there are many different partners in SmartThings, and their domains are really varying from processes and modeling over the self-healing agents towards concrete technology, structure design, durability and sustainability. And there in that slide, you can see the logos of all the institutes and companies who are participating in SmartThings. Actually, we have 11 institutes and companies that are hosting our early stage researchers, and then 11 others that in addition act as supervisor or mentor and that will host secondments of our PhD students. Of course, we have in the meantime established our own website. So for the people following in the live stream and not knowing SmartThings yet, please visit our website, smartthings.eu. And there you can find much more information about our project. You can also register to the newsletter, so I would really advise you to do that, to keep in touch with us and to be aware of all the activities taken in Smartings, the training schools that will also come later, because this is the first actually of 4 different training schools that will be organized. And we also have several of our ESRs being active on social media to make the project better known in this way. Then maybe as regards to the work packages, this is the structure of the project. As I already mentioned, the scientific work packages deal with either improved self-healing concrete, advanced local self-repair, durability, service life and sustainability, or the business aspects, the tech transfer and entrepreneurship. And within the different work packages, for instance, regarding improved self-healing concrete, we consider various self-healing methodologies, like as the use of vascular systems that we want to optimize, the use of capsule-based self-healing systems, bacteria-based self-healing systems, and then to make this all work optimally, we will also optimize the concrete mix design and use models to make it even better. Same for the advanced local self-repair. We will focus on repair mortars and self-healing grouts, and also very local application of self-healing in the concrete cover. This will also be modeled, and we will also implement self-sensing technologies to alarm us when a defect is happening and to tell us when we would need to apply a repair. And then in the third work package, we consider other durability, service life and sustainability. So we really aim at increasing the service life of the structures, and we will study the effect of the self-healing on corrosion reduction, also how we can improve concrete structures under cyclic and impact loading and under extreme conditions. And an extensive life cycle assessment will be carried out. And then in the work package 4, we will link all of this with business models to bring our techniques to the market. Okay, so we had already several meetings. We had a kickoff meeting with all the partners in December 2019. And from the nice picture, you can see that at that time we were still able to join the meeting, well, in person in Ghent. Our second meeting was then actually with all the early stage researchers, the PhD students already present, but unfortunately that was then in June, so we already had to move to an online meeting. And we had really hoped indeed to have this first training school now in Delft, very nice environment, nice team building activities and so on. But I'm sure that in spite of course, we all regret that we cannot be there all together on site. I'm sure that the organization of Erik Schlangen and his team will be very good to make this the best possible online event. So Erik will now introduce you to the topics of the training school itself. So we will know what will happen in the next hours and days.
Okay, thank you very much, Nele, for the nice introduction of the Smartings project. Let me see, I have to organize my slides. Okay. Yeah, so this is the program of our Smartings training school. So we will have 5 days. Today is just started, so we have an introduction of the Smartings training school. And the first day will be mainly focused on presentation on communication and scientific writing. So that will be given by Martijn Makkers from TU Delft. He is a specialist on these topics, and he will, well, I have to correct the live stream. Well, I'm also managing the live stream at the moment. At the end of the presentation of today, we will also have a tour of the microlab. So you will be Okay, so now I think the live stream is okay again. Yeah, that looks good. So at the end of the day, you will also have a visit to the microlab, which will also be virtual, of course, because we cannot be live in Delft. So we will have a virtual tour, nicely prepared by Sean Hay, one of our PhD students, ESRs in the project. So he will take you to the lab and then show you all the facilities we have and tell you about the research we are doing. Then on the second day, we will go to more theoretical knowledge that you need to study self-healing. So we will discuss theory of cracking of concrete. How does concrete fracture? And what do we have to self-heal? How to perform tests that you can do. Then Marina Lukovic will do some upscaling. If you go from material to really structures, what can you do there? How does it work? What kind of tests can you do? How does fracture work on a big scale, and where can self-healing be useful there? So she will tell you all about that. Then in the afternoon we will have Ozan Choporolo talking about microscopy, because we are looking to cracks, inside cracks, and he will tell you how you can use a microscope to study the behavior of this material. And then Paola Antonacci from Torino, she will tell you everything about non-destructive techniques that you can use to study cracking in concrete and also self-healing, of course. So that's the second day. On the third day, on Wednesday, we will move to real self-healing. First, Henk Jonkers will explain different self-healing technologies that you can use. So not only self-healing for concrete, but we'll also focus on other materials a little bit to what is going on there. Then Willy Verstraete from Avicom and Ghent University, he will talk about microbial interactions with concrete and cement-based materials, what these bacteria can do for you, how they can promote self-healing in concrete. And the afternoon on Wednesday will be about modeling. So we will, so myself, Branko Xavier and Claudia Romero Rodriguez from TU Delft will tell you about modeling of fracture, transport, durability and self-healing. Then the fourth day on Thursday will all be about making concrete. Peter Minne from KU Leuven will talk about concrete mix design, theory and packing of how to make concrete. Xavier Farina from Basics, he is from a contractor, also a part of the project. He will tell you about concrete mix design, how it works in practice. How do you apply concrete with the right properties in a practical environment. Then in the afternoon on Thursday, Michael van Leeuwen will take you to the lab. Well, also virtual, of course, because he cannot do that really, but he will show you how you can make concrete in the lab, how you do that, and how you can test things. And then Virginie Victor from Kuchla, she will tell everything about admixtures that you can add to concrete to change your properties in such a way that they are useful. And Friday is a day that we go to a company, at least that was the idea, that we go to Concretify, a company in the Netherlands that does research on concrete towards applications, where they work a lot for contractors and for government organizations to give advice on what to do with concrete, how to study damage, how to improve it, how to repair it. So they will tell you all about that, what they do in their company. So Twan van Kastre and Andrea Blagojevic will lead you to their facilities and tell you about projects they are doing. And that's the end of the training school for all the live attendees that we have. And in the afternoon, we have some things for the project themselves. So all the PhD students from the projects have to do an assignment also. They will work on that in the afternoon. But that's not for the online attendees, unfortunately. So this is the program of the training school. Let's see. These are all the PhD students that are in the project. In European projects, they are called ESR. So we have 15 in total. You will see them also during this week because they will listen to the lectures. They will discuss with the lecturers. They are in this meeting room that we are in. The attendees, they follow the live stream. Attendees from outside, they can still ask questions to the lecturers or to the PhD students. Questions in the Q&A screen that we will see then and that we can forward to the lecturers and they will address them. What I would like to do is now that we go one by one to the ESRs. They just tell their name, where they're from, and in one line what they're doing in the project. So we start with Yasmina. Yasmina, are you there?
Yes. Hi, good morning. My name is Yasmina Shields. I'm from the US, and my project at Ghent University is optimized vascular networks for self-healing.
Okay, Claire.
Hi everyone, my name's Claire. I'm originally from the US as well, but I actually live in Ireland at the moment. But at the moment I'm in the UK, looking at capsule manufacturing techniques and specifically membrane emulsification. Thank you.
Mustafa.
Hello everyone, my name is Mert. I'm from Turkey. I'll be working at Avecom with the partnership of Ghent University on self-protected bacteria for healing and corrosion inhibition. Thank you.
Okay, Harry.
Hello everyone, my name is Hari. I'm from Indonesia, and at the moment I'm working as a ASR4 on the optimized mix design based in K11. Thank you.
Sina.
Hi everyone, I'm Sina. I'm from Iran. At the moment I'm at the Cardiff, and I will working on modeling self-healing in both bulk and local application. Thank you.
Suel. Suellen is not in yet.
Yeah, are you hearing me?
You are here.
Yeah.
Yeah,
Okay. I'm Schlangen. I'm from Brazil. I am University of Cordoba, and I'm developing some cementitious grouts with some crystalline admixture in order to get them more durability.
Priya.
Hello everyone, I'm Priya. I'm from India, currently in the UK. I'll be working on repair motors, trying to incorporate self-healing technology through microcapsules as well as crystalline admixtures.
Sean.
Hi everyone, good morning. My name is Shan and I'm from China. My topic at TU Delft is to develop a self-healing cover for concrete structural components. Thank you.
Gabriele.
Hi everyone, I am Gabriele. I come from Italy and currently I'm in the UK. I work on self-sensing on cementitious systems by exploiting the properties of carbon nanomaterials for damage monitoring.
Thank you. Niranjan.
Hello, I am Niranjan from India. I am currently working on cyclic mechanical and thermal action and impact in Politecnico di Milano. Thank you.
Vanessa.
Hello everyone, I'm Vanessa Capelesso. I'm from Brazil, and currently I'm working at the UGent and Q11 in Belgium. And my topic is related to self-healing in extreme conditions.
Okay. Paradis.
Hi everyone, my name is Paradis. Now I'm in Spain and working at the CSIC. My project is relating to the mitigating chloride and carbonation induced corrosion.
Kieran. Hi Kieran, are you present? I guess not yet. So probably she will pop in a minute. Davide?
Hello everyone, I'm Davide and I come from Italy. I'm currently in Ghent and my task will be to develop a life cycle assessment for self-healing concrete. Thank you.
And finally, Laís.
Hi everyone, I'm Laís Bandeira from Brazil as well. I'm based in UGent and I'm working in the commercialization of self-healing methods and systems and investigate how this technology can be optimally brought to the market. Thank you.
Okay, thank you. Kiran, are you already in now? No, not yet, I guess. Well, this was also a test if all the microphones are working, and I saw the cameras. I didn't show them to you at this moment, but you will all see them later. Let's see. So this will be all the teachers that you will encounter this week. So the lecturers of every day are presented here. So you see already the faces, but you will see them one by one, and I will introduce them whenever they have their turn. So these are the lecturers, and then let's see. Well, we have the SmartThings project that also all the ESRs have to work on this week. The idea was actually, if you would have the live event here, to go to a structure somewhere in the Netherlands, a concrete structure, an old structure which has damage and we should be repaired, and self-healing could really help there. But since we cannot go there, I thought, well, let's go to another nice structure, which is a swimming pool in Portugal, Lequa swimming pools, which are quite nice. I like swimming pools, by the way, so that's why I chose a swimming pool. I cannot go swimming now because they are also closed in the Netherlands. That's very unfortunate, but still, I love to do that every day. And this is a very nice swimming pool in Portugal. It's next to the sea, made out of concrete, a concrete structure in between the rocks. It's built in 1966, so it's more than 50 years old. And of course, this concrete has already some damage. And what you would like to do is to keep this swimming pool for another 50 years, and the ESRs have to make a plan for that in groups. So the pictures look nice, but if you look closer, it has already some damage. Here you see small cracks on the in the walls. Here we see a big crack in the wall. We have overhanging structures, beams. So all kind of things are in there that can be optimized, where we can do repair, where we can replace part of the structure, and self-healing is of course a way to help with that. So you have to make plans how to save this structure for another 50 years, and take into account the environment where it is in. It's very close to the sea, so it's an aggressive environment. Temperature, humidity changes, a lot of water, chloride water inside the pool, salt water outside to the concrete, and still we want to keep this from deteriorating much more, so you have to make a plan for that. So these are the problem that you have to work on. What we also will do on Friday, that's on Friday evening, we will have the first international SmartThings pub quiz. So you will experience that. So we will have nice prizes to win, of course. And we will also have a SmartThings online dinner, which we will have all together from home, unfortunately, but it still can be very interesting to see how that works. Okay, I think this was my part of the presentation. We are ready to start. It's almost 10 o'clock. You can still have a few minutes to grab a coffee, tea, or water. And then Martijn Wakkers, who is already here, he will be the teacher today. He will take over and he will help you making nice presentations and nice publications about the SmartThings project. Thank you very much.